Welcome to Dissolve Chemistry. Let us continue our discussion on this ionic equilibrium. In the previous video, we have discussed regarding dissociation constant of weak acid and dissociation constant of weak base, and also we have seen the relationship between both the dissociation constants. Okay, so in the present video, we will discuss regarding the dissociation constant of polybasic acid and polyacidic base. Okay, let us start with that. Polybasic acid. Okay. So now what do you mean by polybasic acid? Let us take first example. Suppose if you take HCl, so if you dissolve in water, so then what happens? It will dissociate to give H plus Cl minus. Okay. Similarly, if you take H2SO4, okay, and if you dissolve in water, so then what happens? It will give H plus aqueous plus HSO4 minus aqueous. Okay, we know that one. Now next is still this bisulfate ion, what we call. Okay, so that is having capacity to donate still one proton. Okay, so therefore HSO4 minus has capacity to donate, okay, another one proton, and then it forms SO4 minus 2 aqueous. Okay, any acid which has capacity to donate 2 or more than 2 H plus ions, then that acid is said to be polybasic acid. Okay, so therefore your H2SO4, as it can donate 2 protons, so therefore we can call it as what? Polybasic acid. You can take phosphoric acid, okay, S3PO4. If you dissolve it in water, it can donate 3 moles of H plus ions and PO4 minus 3 aqueous. Okay, so these are called as what? Polybasic acids. Okay, so now how these polybasic acids are going to dissociate, and what about their dissociation constant? So let us see that. Whereas your HCl is what? HCl is monobasic acid we call, because it can only donate one H plus. Okay, and we will be having only one dissociation constant for that. So let us see for these examples. Okay, so now suppose H2SO4, when you dissolve it in water, so it will dissociate to give H3O plus plus HSO4 minus. Okay, so Ka is equal to HSO4 minus into H3O plus divided by H2SO4. Okay, water again constant we have taken, that is included in this. Now similarly, okay, already it has dissociated, and this we call it as what? Dissociation constant 1. Why? Because first proton it has given, and still it has capacity to donate another proton. So now further if you take HSO4 minus plus H2O, so then it will be giving what? So it will dissociate to give H3O plus plus SO4 minus 2 aqueous, and this we will give as Ka2, okay, SO4 minus 2 into H3O plus, okay, so divided by H2SO4, HSO4 minus. Okay, this is how we will give. Now always remember the dissociation constant Ka1 is far greater than Ka2. What is the reason for that? Let us see that one. So once it ionizes and gives the first proton, so that it does readily, okay, and after that whatever the ion is being formed, now already it is having minus charge on this, and donation of the next proton becomes very difficult Okay, so therefore the dissociation constant for the second proton will be what? Very low. Okay, compared to this, it will be very low, and it is too high. Okay, we won't give the value, and this is too low comparatively. Okay, so if you compare the values, if A1 is too high and Ka2 is 2.0 into 10 to the power minus 2. Okay, which is comparably, compared to this, it is too low, we can call. What is the reason for that? Because the donation of the proton is now from what? From ion, not from the neutral molecule. Because of that reason, what happens? The difficulty increases. Okay, similarly we will take another one, tribasic acid. Next is S3PO4. It is a tribasic acid. Now let us look into this. So if it ionizes, first ionization gives H plus or S3O plus in water, we can take, and plus S2PO4 minus aqueous. Then next is second ionization, you can take H2PO4 minus plus water. Okay, it will be HPO4 minus 2 plus S3O plus. Okay. Similarly, HPO4 minus 2 plus H2O will give PO4 minus 3 plus S3O plus. Okay. So the dissociation constant we call it as Ka1, Ka2 and Ka3. Okay, so when I compare these three, always remember Ka1 is far greater than Ka2, and which is still more far greater than what you can say Ka3. What is the reason for that? So because as we go from neutral molecule to the ion, as the magnitude of negative charge increases, then donating of the proton becomes very difficult. Okay, so let us see these values. 7.5 into 10 to the power minus 3, 6.2 into 10 to the power minus 8, 4.2 into 10 to the power minus 13. So you can see the value, so which clearly indicates that as you go for the second dissociation and third dissociation, so the dissociation constant becomes very low. Because what is the reason for that? As the charge increases, it is very difficult to donate the proton. Okay, so this is how we can explain dissociation of polybasic acid. Similarly, the same thing we can apply for the polyacidic bases also. Okay, so next we will talk about factors affecting the acid strength. Okay, so let us talk about factors affecting acid strength. Okay, so now suppose if you take the acid strength, if we say that what factors are going to govern this acid strength, isn't it? See, for example, one acid is stronger or it donates proton more readily. Okay, and another will be what? Weaker, or it gives less readily the proton. Okay, so therefore the on what factors it depends upon means, one first point is, that is strength of the bond. Okay, strength of the bond. Second one is the difference in their electronegativity or polarity of the bond, we can call. Second important point is polarity of the bond. So how strength is going to affect and how polarity is going to affect, so that we will see. See, the strength of the bond is how it is influencing the acid strength is. So this we will compare in group. Say for example, if you take acids of 17th group elements like HF, okay, HCl, HBr, okay, and then you can take HI. Now, the strength of the bond goes on decreases due to increase in what? Atomic size of halogen atom. So now what happens, as the size increases, therefore what happens? The bond strength goes on decreases. As the bond strength decreases means what? So the bond breakage will be rapid. As bond breakage is rapid, so therefore acid is said to be what? More strong. So therefore acid strength goes on increases as we move down the group. So therefore HF will be weaker acid than HCl, and it will be weaker acid than HBr, and lastly it will be weaker acid than HI, or HI will be the strongest acid among the halo acids, we can say. What is the reason for that? The reason behind that is, so the bond strength between hydrogen and fluorine goes on decreases as we move down the group. Okay. Similarly, if you take, compare with water and H2S, if you take, so H2S is more stronger acid than compared to your water molecule. Okay. So now the polarity we will compare in the period, not in the group. Okay. So polarity is an important factor that we compare along the period. Say for example, the acidity of NH, okay, and OH in water, okay, and then HF. So when you compare, so then what happens? Acidic strength goes on increases due to increase in the polarity of the bond, or increase in the electronegativity difference between hydrogen and other atom like nitrogen, oxygen and fluorine. Okay, so you should make note of that. Along the period, the strength of an acid depends upon the polarity of the bond, and down the group, if you want to compare, always the acid strength goes on increases as we move down the group, because bond strength goes on decreases, okay, due to increase in the size of the atom when we move from one element to the next element in the group. Okay, so these are the two important factors, so which play important role in deciding the acid strength. Okay, we'll conclude here, and please don't forget to subscribe our channel. Thank you for watching.